Hello, I'm volcanologist Dr. Janine Krippner, and this is my guest.
Hi, I'm Dave Ramsey. I'm a geologist with the US Geological Survey at the Cascades Volcano Observatory in Vancouver, Washington.
Thank you so much for joining me for this special Mount St. Helens 40th anniversary video series. Something that you do is very fascinating to me and many people is looking at the surfaces of volcanoes and what we can learn from looking at the volcano and the landscape itself. And over the last 40 years, this has changed a lot. So can you explain to us what geospatial technology is and what that looked like back in 1980 when they were looking at Mount St. Helens and what it was going to do?
Yeah, the geospatial technology has changed dramatically since Mount St. Helens in 1980. And by that, we mean the process by which you study the surface of the volcano, deposits that are on the volcano, and also the geography around the volcano, where are roads and infrastructure and where do people live around the volcano. All of that goes under sort of the umbrella of the geospatial studies. And in 1980 at Mount St. Helens, most of this was not digital, which is hard to believe looking back from now, where all of us use our phones to find where we are and use GPS in our cars to navigate and go places. At that time, this was pretty much all being done not digitally. It was in hand-scribed maps that were then put on a printing press and made into a map. And it was using techniques that at Mount St. Helens in 1980, it's really impressive what they actually did. There's a professional paper that came out a few years after the eruption that summarized a lot of the thoughts geospatially about what happened with the eruption. It was USGS professional paper 1250. And in there, it's amazing to see what people did in order to record the changes that were happening at Mount St. Helens. At that time, you would have had to go and get an airplane to go and fly at a fixed altitude above the volcano and take photographs. And then you would have to take that series of photographs from the plane back and get rid of the distortion from the camera lens from the airplane. Any camera lens is going to be curved, and you're going to want to take out that distortion so that you can get a nice, flat, registered image where those photographs are registered to the Earth's surface. And you're going to want to do that in repeated sets so that you can see the changes that were happening at the top of the volcano as the volcano was inflating, and as small explosions at the top of the volcano caused pits and craters to form. And so, doing that was a very manual process. You'd have to take the photographs and put them on a PG2 plotter, which is a stereoscopic plotter, and someone would have to sit there, put the photographs together, look through the stereoscope, and scribe contours. And this is the kind of process that could take days to weeks to accomplish. Now, with more recent eruptions, especially what we were able to see with the eruption at Kilauea in 2018, so just 2 years ago now, technology has come such a long way that in order to do that, you can still go and have a plane take those kind of pictures if you want and go through some of that process. Digitally, it will be faster, but a lot of what we use now is folks from our office are trained to go and take digital cameras and go in a helicopter and take repeated photographs as the helicopter moves around the volcano and do what's known as structure from motion. They create the structure of that volcano from the motion that they moved along as their photographs overlapped using software. And it's amazing. It's a lot faster to give you an idea of the relative changes of the volcano, and something that would have been completely unheard of 40 years ago at Mount St. Helens in 1980. They can also do this via UAS. So they can take a drone and fly a drone with a camera and do the same kind of things. You also get the benefits too of really high resolution digital photographs from both the photogrammetric technique using the camera moving around structure from motion and from the UAS. So our ability to collect really high quality images to help us see what's going on with volcano processes has really changed dramatically.
Yeah, we've gone from that taking days to weeks to hours to days, which is incredible. With everything that's changed over the last 40 years, we have satellites now, we have drones. What are some of your favorite tools that we have to integrate this technology so we can help people who live around volcanoes?
I think probably the two most important, one are the advances in geographic information systems in GIS. GIS now, we are able to take so much information and put it into a database and actually pin it to a volcano to say, okay, this is Mount St. Helens, and Mount St. Helens is this tall, and the volume of Mount St. Helens, it is this big, and Mount St. Helens is this extensive on a map, and all that is in a database and pinned to the mountain. Not only that, but now geologic mapping is digital. So where the volcanic deposits are, from those deposits and what we know about the eruptions of the volcano, we can make a volcano hazards map. The hazard map is there now. And then that data can be compared with other spatial databases that are in, around, and near the volcano. So where do people live? Where are the infrastructure that could be affected by an eruption of the volcano? And we can use those databases to put things together and say, oh, here's how we can reduce risk. Here are the people that would be at risk from these volcano hazards, and here's the folks that are vulnerable, and it helps us be able to pass on information to folks in emergency management that make those kind of decisions to help reduce risk. The second is probably LiDAR. LiDAR basically uses, from either an airplane or a helicopter, they use a laser as they fly along at a fixed altitude to record the surface of the Earth. So you're sending many laser beams down, and they're coming back, and you're recording the surface of the Earth and how it changes. LiDAR has really revolutionized our ability to get surfaces on volcanoes. And in a lot of cases, we have really good surfaces right now for most of the volcanoes in the Cascades. So if an eruption happens at any of the volcanoes in the Cascades, that's our base layer. That's our layer to which everything else is going to be compared. Because the volcano right now is like this. If it starts to inflate, we are going to do comparisons and be able to measure. We're going to go and use our photogrammetry techniques or UAS techniques to be able to see that that surface is changing. And that'll tell us something about what's happening at the volcano and the rate at which it's happening.
I can only imagine how incredible it would have been tracking that bulge using the LiDAR, seeing that enormous amount of movement and being able to calculate the volumes. And I mean, I think even with the best we could throw it back now, back in time, it still would have been a very difficult situation. So it's amazing looking back at what they did before we have our current technology. So thank you so much for joining me. I really appreciate you being here.
Thank you.